So we are going to be focusing on drawing Venn diagrams using sets and their subsets. And in order to do so, the first thing we want to do is define a universal set. And the universal set is a set of all elements under consideration, which we're going to write as capital U. So that basically means the overall population or the um, kind of the scope of what we're looking at, and then we'll look at individual sets within that universal set. So let's call this example 1. So let, for example, U be the set of all students at a school. Okay, so that means the universal, I guess, set or the universal population that we're considering are all the students at the school. So we can look at other sets within that universal set, for example, all the female students, or all the male students, or all the students who wear glasses, etc. Those sets within the universal set are what we call subsets. So those are just some examples of subsets that lie within U. So to formally define a subset is basically um, if every element in any set, for example M, is an element of another set, then M is a subset of N. So basically, just as long as all the elements inside one set are contained in another, it is a subset of the other. Your subset can also equal the original set. Okay, so the notation that we would use for any subset is the set that you're considering a subset, and this kind of sideways U or this elongated C, and a little line under it, and then what it's a subset of. So M here is a subset of N. The reason why we add in that little line underneath is what I just said earlier. Your subset could possibly be equal to the original set. That's why we have that line, kind of like your greater than or equal to and less than or equal to inequality signs. Now, we could also have what's called a proper subset. So a proper subset just can't be equal to the original. That means it's actually just a smaller group within the original set. So a proper subset um, is of a given set is one that is not identical to the original set. Okay? So now, for example, if M is actually contained within N and not equal to N, then what we do is we just take away that little equal to line and say M here is a proper subset of N. So this means M cannot equal N. Okay? So that's some notation for subsets. All right, let's take a look at some notes here. So something to note that the empty set is a subset to every set, right? Because the empty set is empty, so every set could be, narrowed down to just the empty set. So the empty set is a subset of every set, but the empty set is not a proper subset. Okay? So that's something to make sure you clarify. So you would say something like the empty set is a subset of, for example, U, right? That's okay, but you would never say the empty set is a proper subset of U. This is not okay. So it's just a subset, not a proper subset. Okay? And the whole reason why we talked about the universal set is we need the universal set to help us properly define a set and then create our Venn diagrams. Okay, so that universal set helps us properly define a set because it tells us what that set lies within, right? What kind of universe does it come from? And we use that then to create Venn diagrams. All right? So the Venn diagrams that hopefully you guys have seen before are basically these circles, right? They either overlap, they intersect, they might be nested within each other. So a Venn diagram is basically any type of set diagram which depicts the universal set as a rectangle, kind of like a mat, and any set under consideration as a circle within the rectangle. Okay? Um, So in the second example, let's let U be, once again, the set of all students at a school. Okay, and then let's let set A be the set of all ninth graders. Okay, and let's let B be the set of all 12th graders. So we can take the situation of U, A, and B and create a Venn diagram. So this rectangular mat shape picture will be U. So within this rectangle are all the students at the school. Right? And then you have two sets within U. A would be the set of all ninth graders, right? And then B would be the set of all 12th graders. They are not touching here because you can't be a 9th grader and a 12th grader at the same time and vice versa. So this is one type of Venn diagram where your circles may not actually intersect. In today's lesson, we are focusing just on subsets. So look at intersecting sets in the next lesson. So how would you draw a subset? Well, a proper subset is drawn as a circle within a circle. Okay, so just a quick sketch. If you had something like some set M is a proper subset of N, which is also a proper subset of U, this would be your situation. Here's your universal set. Then here would be N, right, working your way toward the left. Then M would be the smallest one contained within N, right? So that means all of M is inside N, and all of N is within U. Okay? Ooh. Okay, let's look at one more example using Venn diagrams and subsets, and then you can try a few, and we'll check that in class. All right, so let's let U be the months in a year. Let A be the months of the year that end in Y, and B the months of the year that end with, or that start with the letter M. We're going to draw sets U, A, and B in a Venn diagram. So if it helps, you can always write down the elements of each set. U hopefully is pretty obvious, it's January through December. But A, if you want to think through what months actually end in Y, well, we've got January, February, March doesn't work, neither does April, but May does. June doesn't, but July does. Then we've got August, September, October, November, December, all ending in different consonants. And then B, the only month that starts with the letter M would be May. So the element of B would be May. So how can I draw this Venn diagram showing our sets and subsets? So remember, always, always start with U. So you know that my universal set's going to be all 12 months, right? Then we're going to have our set A, labeling the circle and thinking about what goes within A. And then finally we have B, which will be nested within A. In this case, because May is repeated in both A and B. So what I like to do is I like to work inside out. Since I know there's only, oops, B instead of M here. I only know there's only one month that repeats. I'm going to go ahead and put May in that nested subset. Then the other 3 months, January, February, and July, just hang out in A but not within B. And then the rest of the months are going to be outside in the universal set because that still contains all 12 months. So we want to go through and add in March, April, June, August, September, October, November, and December. So anything that's not contained within a defined set will still be in the universal set and needs to be depicted out in that rectangular space. Okay, so enough from me. A few problems for you guys to try. Please come back to class with these done, and we'll go over the answers and talk about any questions when you come back. Thanks for listening.